Hi guys, and welcome to another quick physics minute. Today we want to talk about electricity and some things that deal with it. If I have a light bulb like this with some wires attached, I can have some batteries attached to the end of it. Here, if I have one like this, or I've got this weird square looking one. If we take a look at this, it says 1.5 V on the side. That means it has 1.5 volts of electrical potential difference. That sounds kind of like a weird term, so let's just show what that means. If I take that cylindrical battery, which we call a D battery, and attach the two terminals that we have here set to the light bulb, we find that this thing goes ahead and it turns on just a little bit. Okay. Now, if I go in and take this thing and I replace it with what we normally call a 9-volt battery, we find it provides 9 volts of electrical potential difference, and it shines quite a bit brighter. So what all is going on here? Well, this shows the idea of electrical properties in 3 different terms that we want to talk about. First of which is indeed voltage. Voltage, what we abbreviate with V, is measured in volts. It's kind of weird. We say voltage for volts, but we don't say kilogramage for mass. It's just something that we do for voltage. It's the electrical potential difference. If we were trying to describe electricity as water, it's like the water pressure in a system. An easy way to remember what's going on with the idea of voltage is volts are the energy per charge. It's the push per charge. It's the thing that makes the charge move. Notice when I used a 9-volt battery, we had more push. Now, as we have more charge moving, we then start talking about the idea of something called current. Current, we use a capital I to show it. It's like electrical intensity. It's measured in amps. We use an A to show that. It's the flow of electrons. And if we compare it to water, it's like the flow of water. And the big thing with current is it's charge per time. It's not a speed, it's amount of charge flowing in some time instant. Now, all that stuff can change when we have different things set up. Now, I have a very specific light bulb here, but if I was to try to make it a different light bulb, I'd be changing the parameters of the circuit. In that case, I'd be changing what's known as resistance. Resistance, which we use a big capital R for to show, we measure in ohms, and we use the symbol omega to show it. It's the difficulty for charge to flow through something. In terms of water analogy, it's like the water, it's the diameter of the pipes. So if we have 2 situations like this, and we've got a pipe like this, water would be fairly easy to move through, but it's going to be a heck of a lot easier if we've got a pipe like this. In this case, they have similar lengths. That's an idea that we can talk a little bit later. But we notice in this case, it is indeed wider. So we notice it's going to be easier for charge or water to flow through this one. So what we mean by that is a type of relationship where if it becomes easier, that means we get more of this when we provide more of this. Again, this is the ideas of voltage, current, and resistance. Thanks, and have a great day.